So the electricity experiment, the experiments related to voltage, current, and resistance. As you can see, a student is investigating a resistance of a three wires, A, B, and C. What student did? He's using the circuit as shown in figure 2.1. The circuit is set up to test the wire A. The length L is there of each wire is measured and recorded. So first a wire A is there. Using a crocodile clip, it is clipped from the ends and the current is measured. Then the wire B is there, which is like using a crocodile clip. You will clip it wire B ends and then C. On the figure 2.1, draw a voltmeter connected so that it can measure the potential across A. If I want to measure the voltage across A, how I should connect a voltmeter? You can use screen annotation for that. How a voltmeter should be connected to measure the voltage across A. Yeah, you can connect here, even you can connect here. This part also voltmeter, that's fine. You connect it down, that's also because voltmeter is either up or down. But if a student did like this on the wire or voltmeter, then it is wrong. Why? Because this won't record the total voltage of A. Because we want the total voltage across this length of a wire. So this is not across the total. So that's why this won't be correct. It should be from beginning till the start. It should be from the start till the end or beginning to the end. In the first line of a table 2.1, record the potential and the current. So what is the voltage and the current reading? How much is the voltage and current? So it is 2.7. Yeah, that's right. And what is the current reading? The voltage is 2.7. What about the current? Zero 0.48. Yeah, that's right. Because each line is because look, 10 lines are there representing 0.2. So each line is representing 0.02. So this will be 0.42, 44, 46, and 48. So that's why 0.48. Then student connect the crocodile clip B and C and he read. Then calculate the resistance. How to calculate a resistance? The formula is given. Resistance is voltage divided by current. So voltage divided by current, complete the last column for resistance of each. Use same number of significant figure for each of them. Like better 3 significant figure, your answer should be in 3 significant figure. So 5 point, if it is 5.62, you can say. What about the resistance of the second one? Three significant figure, like, because these are 4 significant figures, so use 3 significant figure. Because the best answer should be 3 significant figures, so write as this as 2.59. Same thing, you rounded off to 5.62. And what about this one? 3.2 is there, so 3.20. The next, calculate the resistance per length for each R over L and include, so resistance per length means like resistance divided by length. So A was 0.9, B was 0.5, and C was 0.4. So we got the resistance of A. The resistance of A when we calculated using a formula. So it was 5.62. Resistance of B when we calculate it was 3.20. And resistance of C when we calculated it was 2.59. The length which was given, that was 0.900. That was 0.500. And the third one, I think it was 0.400. These are the lengths Yeah, 500. So we want resistance per length, means resistance divided by length. So what is the resistance divided by length for A? Means 5.62 divided by 0.9. 0.900 is same as 0.9. What's the answer for a resistance per length? 5.62 divided by 0.9. You can use screen annotation to complete. So 6.24. What about the second one for B? 3.2 divided by 0.5. 6.4. So if it is 6 point, because the same number of significant figure, so you should write as 6.40. Even it's 6.4, but write 6.40. And what about the third one, 2.59 divided by 0.4? So this will be 6.48. And the unit is also important, as you have to complete the unit, including a unit. So unit of the resistance is ohm and the length was given in meter. So what is the unit here? So we'll write ohm meter. Ohm meter, ohm meter. Or you can write ohm meter minus 1. The next part, another student suggests that R should be same for each. Like our values were, this was 6.24, this was 6.40, this is 6.48. Are the values equal? Yes or no? State whether your result support this suggestion and justify the statement with reference to your result. Are the values equal? You can work out the percentage
Yes,
difference.
they are within the limit of
You can work.
scientific accuracy.
You can work out the percentage difference. What is the percentage difference? Percentage difference is maximum minus minimum divided by mean into 100. If your percentage difference of the values is more than 10, we will say no. If your percentage difference is less than or equal to 10, we will say yes. So you can work out by the percentage difference. What is the percentage difference here? What is the maximum value for us? The maximum value is 6.48. What is the minimum value for us? That is 6.24. Divided by mean. What is the mean of these three? 6.24 plus 6.40 plus 6.48. Take a mean of that. 6.24 plus 6.40 plus 6.48. That divided by 3. So the 6.37 and into 100. When you subtract 6.48, 6.48 minus 6.24, which is 0.24, divided by 6.37 into 100. So our percentage difference is coming out what? What's the percentage difference? So our percentage difference is how much when you solve? 3.76. So if it is, our percentage difference is 3.76. So we will say yes, within the limit of experimental accuracy, like the values are within the limits of experimental accuracy. Or you can also use the term that the statements matches the result, that is within the limits of experimental accuracy, the values are equal. And statement matches the result, you can also say. Is it clear, this one? How we work out that whether values are equal or not?
Yes, sir.
Okay. Then the student measure the length of each wire to be tested. On the figure, draw an arrow, means two direction arrow, indicate precisely between the 2 points that he should measure. Like what is the length he should measure? You can use screen annotation. Like which part he should measure? The length. Yeah. So you have to draw, yeah, so two arrows, yeah, that's right. So you have to draw two direction arrow. So you have to draw from here one arrow to other side. That's it. That is the length student should measure between the two crocodile clips. One possible problem with this type of experiment is the heating of a resistance wire. Usually, this is a common problem with the electric circuit questions in which when or electrical in which we are electrical devices or appliances that it become hot when the current is passing. So how we can reduce the heating effect? There are different ways to reduce the heating effect. Number one, we can reduce the supply voltage, or we can switch off between the readings. Like circuit should not be remain on for a longer period of a time. We record the value and then we will switch off the circuit so that because the current is passing for a longer time, it will produce greater heating effect. So reduce the supply voltage or reduce the current